Hey, today we're going to talk about polynomial functions and the graphs and analyzing the graphs of a polynomial function. So first we need to decide what is a polynomial function. A polynomial function is one that typically has the form of a sub n, x sub n, plus, and it decreases as we put a polynomial into standard form, going from, for example, a cubed to x squared to x to the first power until we get down to the last one, which is the constant function. An example of a polynomial function is the one located here, where we have exponents and we have terms. This has 1, 2, 3, 4 terms. This is a polynomial. Polynomials can't have negative exponents. If they have a negative exponent, if you recall, that means that they would have variables in the denominator. So we can't have a variable in the denominator. Or it can't have fractional exponents, such as x to the 1/2, which you should recall from Algebra 2 is the same thing as the square root of x. So, examples of polynomials. This is a polynomial. Once you set it equal to an equation, this is a polynomial equal to 0. This is a polynomial equation. And if you begin with f of x or y, this is a polynomial function. So the first thing we're going to do is look at a polynomial function or a function and determine if it's a polynomial or not. So if we look at number 1, we need to look at the variables. And the variables here is in the denominator. So I would say that this is not a polynomial. The directions say if it's not, we need to say why it's not a polynomial. So why? Because it has a x squared in the denominator. Okay. We go on to number 2. Looking at number 2, I don't see any variables in the denominator, no fractional exponents, so this is a polynomial. If it is a polynomial, we need to state the degree. The degree is the highest exponent that you see. So the degree is 2. The leading term is the next thing I want to say. What does it start with in standard form? Or what is the term that has the highest degree? Is 2x squared. The next thing we need to talk about then, what is the constant? The constant is the term without any variables, so the constant is 1. And then we need to write it in standard form. So we start with the highest exponent, the term then with the next highest, and then continuing down. So this would be our polynomial in standard form. Looking at number 3. If we look at our exponents, we see right here we have a fractional exponent. So we would say that this is not a polynomial. Why? Because it has a fractional exponent. Okay, looking at the last one here. I don't see any fractional exponents, and I don't see any variables in the denominator, so this is a polynomial. The degree is my highest exponent, so it has a degree of 3. My leading term, if I want, sometimes it's easier to put it in standard form to see this. We start with our highest exponent, negative 3x cubed. There's no x squared, there's no x's, so then we would just say plus 5. So my leading term is negative 3x cubed. And my constant term is 5. And this is my polynomial in standard form. So again, the first thing you need to make sure you know how to do is recognize whether it's a polynomial, find that leading term, and find the constant, because that's going to tell us important information later. So let's look at some of this important information on the back. So if a polynomial has a degree n, then it has that many zeros. So if the degree is 3, it means it'll have 3 zeros. If it is 5, it means it'll have 5 zeros. The multiplicity of a real zeros refers to the number of times that zero occurs. So for example, if you had x plus 2 squared, that means it would have a zero, two zeros because it's squared. Let's see how this actually works. So if the multiplicity is even, then the graph touches the x-axis at the x-intercept. If the multiplicity is odd, then the graph crosses the x-axis at the x-intercept. So let's look at this example. I gave you the polynomial in factored form, so I know it has 3 real zeros because I see 3 x's. So there's a 0 at, what's going to make this be 0 is 1. What's going to make this be 0 is -2. And what's going to make this be 0 is 4. So it has 3 zeros. Since all of these are not raised to any power, they all have a multiplicity of 1. Since it's an odd number, it means when you graph this equation, it's going to cross over that at the x-intercept. Okay? So let's look at example 2. It has x squared, so 2 zeros and a third 0 here. So it has 3 real zeros. One of them is at -1. Since it doesn't have an exponent raised to a power, it has a multiplicity of 1. So I'm going to say m1. And another 0 is -3, because if I plug -3 in here, that's going to give me 0, and it has a multiplicity of 2. So since this has a multiplicity of 1, we know it's going to cross at the x-intercept, -1, 0. Since this has a multiplicity of 2, we know it's just going to touch at -3, 0. I'd like to say sometimes that it bounces off when it hits that point and goes back in the opposite direction. And we'll see this as we start to do some graphing. So trying number 1, again, there's a 0 at 1. It has a multiplicity of 2, which means it touches the graph at the graph touches the point 1, 0. Another 0 is -6. It has a multiplicity of 1, which means that it crosses through the x-intercept, -6, 0. 1, to make it be 0. We know it has a multiplicity of 2, which means, again, that it touches. So my x-intercept is at 1, 0. We have another 0 at -6 with a multiplicity of 1, so reviewing that it crosses the graph. So we have another intercept at -6, 0. How do I find my y-intercept? Well, hopefully you remember now all you do is plug in 0. So I'm going to have 0 minus 1 squared times 0 plus 6. So 1 times 6 is 6, so my y-intercept is 0, 6. Trying again for number 2. We don't need to, this was just review. Let's just list our intercepts. We're going to take a break there. In part 2, we'll graph and write equations of polynomials.